All right, welcome everybody. This is section 7.7, fluid pressure and fluid force. There's a couple of formulas we need. Let's take a look. Yeah, it lets me go there. Oh. There we go. Let's start off with pressure. Pressure is W times H. W is the density. And H is the depth that the item is in the liquid. What depth? So I would write this down, P equals WH. And just knowing that W is the density and H is the depth. And that's kind of, I think this is an important part, understanding the depth. Anybody know how deep a submarine goes? Just asking. Here's the ocean. How deep does a submarine go? So somebody take a guess. Anybody want to take a guess?
2,000 meters.
That sounds really deep. I think that's too deep. Yeah, no, but that's fine. What I wanted to hear from you is 2,000. When you're down, it's the depth is the feet you are down below. So it's not negative. I just want to make sure when you say, how deep is it? It's negative 2,000. No, it's 2,000 feet deep. So I just wanted to make sure we say that once, because there's in the formula, there's a negative in there that people get confused about. And I don't want people getting too confused. So I just wanted to show you, hey, yeah, it's deep. 500 feet deep or 1,000 feet deep. Here are some of the weight densities for fluids. The main one you need to write down, I think this is not on the test, but you need to know this. It's on the test, but they might not give it. Water is 62.4. So that's just regular water, 62.4 pounds per cubic feet. Pounds per cubic foot. There we go. So that's the main one. I think if there was any of these other ones, they would tell you what it is. If you notice, seawater is 64.0. But normally, I think the book wants you to know water. So have at least water written down, 62.4. Sometimes they don't tell you. Let's see what's important here. Once again, H. It's the amount of pressure exerted by a fluid at a depth of H. Pascal's principle states the pressure exerted. I just want to know H is the depth. Once again, it's not necessarily when you say depth, you don't say a negative number. So that's just a key. You say it's 20 feet below or it's 20 feet deep. All right, we'll get to it already. Okay, so we wrote down first P equals WH. Now we need to write this formula down. F equals pressure times area. So this is key. You wouldn't have to write that down. It's just taking the A to the other side and dividing it. But do write down F equals pressure times area. The fluid force on a submerged horizontal surface of area A. Okay, so now that we have those two written down, find the fluid force for a rectangular metal sheet measuring 3 feet by 4 feet that is submerged in 6 feet of water as shown. Okay, so first of all, let's put the two formulas down that we know so far. We know pressure equals the density times the depth. And then we know fluid force equals the pressure times the area. Let me put that over here. Pressure times area. So here, it does tell you submerged in water. So the density in water, what did we say it was? 62.4. And the depth in water, 6 feet. You see the plate is submerged 6 feet. So pressure equals whatever that equals. 62.4 times 6. 374.4. So I'm going to bring it over here. 374.4. Now we need to find the area of this rectangle, and area of a rectangle is length times width. Length, you can call it 4. Width, you can call it 3. So the area is 12. I'm assuming it's feet, yes. Everything's feet, so times 12. And then it tells us our force. And you have a couple homework problems like this. I don't think there's one like this where you're not integrating on the test, but you do have a couple of homework problems that are similar to this. So that's what I got. Let's see if they worked it out. I think they worked this one out also. Let's see if we got the same thing. 374.4, and then the area was 12. F equals P times A, and that's it. That's the force. And if you notice, it says here the fluid force would be the same in a swimming pool or a lake. Would it be the same in an ocean? Said the fluid force would be the same in a swimming pool or a lake. Would it be the same in an ocean?
No, because the water density of salt water is different.
Exactly. Remember, salt water was 64. Now, I'm sure the density changes a little bit in a swimming pool when you're adding chemicals and stuff like that. You're adding, some swimming pools don't add any chemicals. What they add is salt, and they have that machine that takes the chlorine, right?
My mom had a saltwater swimming pool one time.
Yeah, they put salt in this thing and it ionizes it. NaCl is salt, and they break it up to where you have sodium and you have chloride, and then it puts it in the pool. So I had one of those pools once. And that's pretty cool. All right, so here's the next formula we have to write down. So here's the one that will be something like this will be on the test. The fluid force exerted by a fluid on constant weight density, blah, 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 against a submerged vertical plane region from Y to C to Y to D. In other words, we're going to take the derivative with respect to Y because this is the y-axis and this is the x-axis, and we're worried about the submersion, whatever it is down below the water line. So this is going to be the y-axis. So we're going to be integrating from somewhere to somewhere up here on the y-axis. So hy is the depth of the fluid. And ly, this is kind of weird, but this is it, is the horizontal length of the region of y, the horizontal length. This is the depth, and this is the horizontal length. And that's the key to the whole problem, that ly. Usually that's the key. So we definitely want to write that down. Oh, by the way, if you look, the integrating density is right outside of it. W, the density is right outside of the integration. So let's write that down. And guess what I did? Oh, no, I hit record. Good. I just want to make sure I'm recording this. All right. So a vertical gate in a dam has the shape of an isosceles trapezoid. What? 8 feet across the top, 6 feet across the bottom, with a height of 5 feet as shown. What is the fluid force on the gate when the top of the gate is 4 feet below the surface of the water? Okay, so we are going to work on this problem. The next slide is going to help us out a little bit. This is kind of cool, but the next slide actually really helps us out. If we look here, it gives us these coordinates. And right here is the origin. That coordinate is 0, 0. So if you look, it says, in setting up a mathematical model of the problem, you are at liberty to locate the x and y axis in several different ways. But they tell you the best way to do it if you had to do it. A convenient approach is to let the y-axis bisect the gate. It's right down the center. The y-axis is right down the center. In other words, this distance is the same as this distance. And then the x-axis is the surface. The x-axis is the surface. So the depth of the water in feet is negative y. So this is, people get this confused. The depth of the water, the formula that we use for the depth of the water is negative y. Because if we look at this, this is negative 2 feet. So if I put negative 2 in the y, do you see it becomes positive? So negative is positive. So this is a positive 2 feet below the water line. The reason why we put negative y is when you put the number, if it's on a number line plane like we set it up here, when you put negative 2 in there, we end up with a positive 2. And then we can say, oh, it's 2 feet below, because the formula is for how many feet below the water line is it? So we can't say it's negative 2 feet, it's 2 feet below the water line. So to get a positive 2, we have to use negative y as our formula for below the water line. And that's a little confusing to some people, but just know that we're using negative y as the distance below the water. Because if I put a negative number in there, like if we set up with a coordinates, it becomes positive. Okay. So that's, let me go back up to the formula really. Well, I can write the formula here. Formula was, if my pen lets me. So negative y is the hy right here. So this is the distance. Remember, we talked about h is the distance below the water line. How deep is it? And we put negative y there. Now the ly, that's the hard part. Ly was the horizontal length. It's this horizontal length right here at any given point. It's the horizontal length at any given point. So we have to somehow create an equation with respect to y. We have to have an equation with respect to y because we're integrating this with respect to y. So we have to have an equation with y's in it that will tell us the horizontal length. And this first one's going to seem tricky, but after that, we're going to do one example in the homework. And I think once, as soon as we do the one in the homework, it'll all come to us say, oh, that's why we do it. So we need to find a formula. So I'm looking at things that I do know. And this is a little strange, but I do know the coordinates for those 2 points. So what I'm going to do is I'm going to find the equation for this line. I am going to find that equation. So my coordinates are 4, -4, and 3, -9. Okay, so I'm going to use these 4, -4, and 3, -9, and I'm going to find the equation for that line. Let's see if I can remember that by the time I turn the page. 4, -4, and 3, -9. Well, maybe we should have read that last part. Let's go back up. There. To find the length ly of the region, find the equation for the line forming the right side of the gate. That's what I plan on doing. Finding the equation for the right side of the gate, because we know those coordinates. They gave us those coordinates. And I think if we looked at that other picture, we could actually create those coordinates ourselves. And maybe I should see here. Do you see this is 4 down? And if we're right here in the center, this is the origin right here. So this would then be down 4. And since this is 8 feet and this is 4 feet, so this would be 4, -4. This is the x is 4, y is -4. And then if we went down even more to here, this would be 3 and 3, which is 6 total. So the x would be 3, and then the y, we already went down 4, but we're going to go down 5 more. The y would be -9. Okay, so we can create this ourselves if we had to. I just wanted to show you, we could create that ourselves. And I don't know if they wanted us to do it. Maybe they did. It's good to have it there, but we did create it. 4, -3, 4, -4, and 3, -9. So I'm writing those down, and we're going to write that equation. 4, -4, and 3, -9. This was the equation. And so first I'm going to find the slope. y2 minus y1 over x2 minus x1. And I'm going to put this 3, -9 here. And I'm going to call this the first point. This is x of the first point, y of the first point. X of the second point, y of the second point. So this is just algebra, right? Y2 is -9. Y1 is -4. X2 is 3. X1 is -4. So it's 3 minus 4. So on top, I get -9 plus 4, which is -5. on the bottom, I get a -1. So my slope equals a +5. Okay, so y equals, oh, I'm going to use the point slope equation because I have a point and a slope. Now, I don't know which point they use. I'm not sure. I'm going to use this point. But if you use the point slope formula, this is all algebra. It's y minus y1 equals the slope times x minus x1. So y minus y1 was a -4. The slope we got as 5. X minus x1, which is x1. Oh, I wanted to use this one. I said I was going to use this one. I'm sorry. I think that's the one the book used. If not, we should still get the same answer. It doesn't matter which one to use. Y minus, I'm going to use this point. So I'm using this as y1, then -9. I wonder if it matters. Or x1 is 4. It shouldn't matter which one we use. So this is y plus 9 equals, distribute 5x minus 20. Take the 9.
Wouldn't it be 3 x minus 3 since you're using the 3 -9?
Oh, yeah, yes, thank you. Thank you. And so there should be a 3 there. So that should be 15. Yeah, that would have messed everything up. Take a -9 to the other side. 5x minus 24. But we have to set this where we're going to integrate with respect to y. So I need to find out what x equals. So now I'm going to take the 24 over y plus 24, and then I'm going to divide by 5 equals x. So what I did was just isolate the x. I got the 24 to the other side by adding 24, and then I divided by 5, and this is what I get. So I get y plus 24 over 5 as my x. So I'm just going to write that down for a second. Let's see. And then we'll go to the next slide. And I'm sure they're going to have all the work for us there too. Okay, they used, yes, same thing. And then we solve for x, y plus 24 over 5. Okay, so this is where I got it. Now I want to take us back. I'm going to show you something. I want to take us back to the picture. So let's go back to the picture. Let me erase that circle. So our formula was x equals y plus 24 over 5. When y, do you see right here, y equals a -4. The y equals -4 here at this point right here. If I put -4 into the formula, -4 plus 20 is 20. -4 plus 24 is 20 divided by 5 is 4. X equals 4. So they're showing you that x equals 4. However, the ly is the length of ly has to be this entire length. And since we bisected this side is also 4. So when we did this, we calculated and found this x, but we have to multiply this x times 2. I mean, if we go down 4 more feet or whatever, it doesn't matter how many feet just let's say 2 more feet, we'll find out what this X is. And let's just say 6. If this X is 6, this X is also 6, or it would be less than 6, sorry. So let's say it's 3. So the whole thing, 3 and 3 would be 6 instead of 8 across, it'd be 6 across. So that's what this is doing. We're calculating this distance, but we have to multiply it by 2 to get the whole distance across. It's this distance times 2, so we get the whole thing apart. So I just want you to know that before we go to that next step. And they show this in this down here. Okay, take whatever we had from X and multiply it by 2. So when I do that, so then we do just multiply. You can just do this, multiply it by 2. And this is what we get, 2/5 y plus 24. That's our Ly. Ly has to be that X, but you're going to multiply it by 2 to get the whole thing, because we said the line bisected that steel plate. So Ly will be whatever we get for X, and then we multiply it by 2. I mean, there's a lot going on here. So now we do know the H is the negative y. And here's our Ly that we multiply the X by 2. So in reality, this is 2X right here. And then if you go back to the picture, we're integrating from -9 to 4. Let's go back to the picture really quick and read it. I mean, I wasn't even worried about what we're integrating to yet. I wanted to get to that formula. That's the setup. That's the main part that we wanted to see. And if you see, it says we're integrating the whole plate from -9 to -4. Okay, so I mean, this is the setup. When I say this is the setup, you can't continue. I mean, the integration can't be done unless everything is written down here correctly. So this, I mean, on a test, there are a couple of problems that say, you know, we want you to find the fluid force on that steel plate below. And then they give you 5 answers of a setup. So you have to pick the correct one. So you have to go through it and see which one matches the way you got it. And then you can go through and integrate it. If you integrate it, you have to, first this 2 5s can go out, 62.4 with 2/5 on the outside. And then we're going to distribute. I get, I think you can take the negative out also. I think that's what they want you to do. So I'm going to take the negative out. So y times y is y squared. Y times 24 is 24y. And now you integrate this with respect to y. You end up with y3 over 3 plus 24 y squared over 2, integrating from -9 to -4. And this stuff still has to multiply it at the end. And so let's, I know they'll have all that work for us. I'll give you a second if anybody's writing this. I think they show all this also. So let's see what they do show, if I can get to it. There we go. Yeah, they show they don't really explain a lot, but they do show that the 2/5 came out and the negative came out. And then we integrated we multiplied then, and then we integrated. And then you plug the numbers in, and I'm not going to plug the numbers in, but you guys can, and I think there's an answer somewhere. Yeah, they do a little bit more. And then finally, they get that answer. So Ly, once again, is the distance of X, the distance across, and in this case, it's the X, and this was the Y, how deep down, and we use negative Y because we're saying it's 5 feet below. We don't say negative 5 feet below, but if we put negative 5 into it, then the the Y becomes a positive, and that's why we say 5 feet below. All right, so that is the PowerPoint. So I want to go to the homework. There's at least 3 problems in the homework I want to do. And there's one similar to this, and we'll do that again. I kind of remember them. Well, I'll let you know more. Well, you'll see it in the show your work. I think there's one similar to that or similar to the one we're going to do in the homework on the test. Let me get to the actual homework, if I can figure out how to get there. And I thought I marked which homework problems I wanted to do. Oh, I thought I did. Where did I write it down? Oh, 1, 4, and 6. So the area top side of a piece of sheet metal is given. There's the area right there. The sheet metal is submerged horizontally in 5 feet of water. Find the fluid force of the top side. Water and density is 62.4. And I think on the test, they don't give us the density. So once again, fluid force is the pressure times the area. And if we need to figure out the pressure, which is the density times the height. So density is 62.4, and the height right here is submerged horizontally in 5 feet of water. So the pressure equals 62.4 times that, and no, that that doesn't seem right. Wait, what's it asking? Yeah, that's it. Whatever 62. They didn't actually show that. They just did it. That's okay. 62.4 times 5, and we get 312. So 312 goes here. They didn't show in the work 312. They just left it unmultiplied. And then the area. Here's the area of the thing that's submerged. They said it's 2 square feet. So the fluid force is just multiplying those two together. See, those are easy. A lot different from that last problem we just did. Once again, I mean, you got this one on the homework, and I think you have another one similar like this, similar to this. Not too bad. Yeah, number 2, there's this same thing. Number 3 is really similar also. And I am going to put the homework stuff there. I want to remind again, I'm begging you, please don't use that homework solutions unless you're stuck to get you going, because if you rely on it too much, you're not doing enough thinking. You're not doing enough thinking. Okay, so here we go. Find the fluid force on the vertical side of a tank where the dimensions are given in feet. Assume the tank is full of water. So this is a tank and it's full of water, water density. Round your answer to 2 decimal places. So once again, we are going to integrate this, and W integrating the height or how deep this item is, and this is the Ly, the distance, what X equals, the X value. L is the X value at any point. And do you see it's right down the center? So the X value should be doubled. Okay, so we'll find this X value, and then we have to double it because we want to find the entire distance across at any given point. And it says the fluid force, once again, it says the tank is full of water. So how deep is it? This is, we know it's 9 feet deep. So, I mean, here's the answer that we want for HY, but we need to understand how they got 9 minus Y. Can anybody tell me why we're using 9 minus Y?
Because you're starting from the 0.9, right? And then you're subtracting the Y value to find that point that you're looking for.
I look at it a little. I look at it a little different.
I would say it's kind of like we used to do in 7.1, finding the shade under the line. So if we
Yeah.
flip this on the other side, flip it vertically, we would be finding the shade under the 9th height.
Yes.
That's what I would say.
So I mean, if yeah, because we're not using an axis or anything. I had a very good answer for this. I mean, if you plug 0 in here, if you plug 0 into Y, then you, do you see this thing is, the fluid force is, I guess, this is how I would look at it. If you plug 0 in here, then you have 9 feet of water. If you plugged 1 in Y, now you only have 8 feet of water. Plug 2 in for Y, you have 7 feet of water left because it says it's filled. I mean, it's kind of hard to explain that, but it is 9 minus Y. That's what we're using for H. Now the LY, that's a little, it's a little trickier. It's a little easier for this problem because they give us this formula. This is a parabola, and they give us the formula, y equals x squared, but we have to set it to x, so we square root both sides, and x equals the square root of y at any given point. So if I say, this is 9 feet deep. I guess we would say 9 feet deep. There's no, I don't know how to say that. But anyway, if we solve for x, this is what we get at any given point. This is the distance x equals the square root of y. And it only gives us this X value at this point. So we have to multiply it by 2 to get the whole thing across. We have to multiply that by 2. So that's 2X. So if you look at the LY, 2X, that's 2 times the square root of Y. We have to multiply that LY times 2 to get that, to double the X value. Okay, so from there, let me erase this mess. From there, we integrate, oh, they have all the integration there. We're integrating from 0 to 9, the distance that we have, and the density, and then we have the HY and LY. HY, we said, was 9 minus Y. And LY would be 2 times the square root of Y. And we're going to bring the 2 out in front. And the density is out in front, 62.4. And then we're going to bring a 2 out in front of it. And that's how they get this. So 2 times 62.4, integrating from 0 to 9. 9 minus Y times the square root of Y. And you can go through the process. First, you have to distribute this. And instead of Y, we're going to use Y to the 1/2. Same thing. So we get 9Y to the 1/2. And Y to the 1/2 times Y to the 1 is Y to the 3/2. And then you integrate it. You add 1, which is 9 to the Y over 3/2. Then you put the 3 on the bottom and the 2 on top. And if you notice, you reduce that and you get, they show you that you got 6. Here, if you add 1, you get Y. 1 is 2/2. So you get 5/2. And so you put 5 on the bottom and 2 on top. And that's what we get over here. And then once you plug in all the numbers, they show that on the right-hand side. Once you plug in all those numbers, I'm going to clear this. Once you plug in all those numbers, this is what you get. And it gives you the fluid force. That was, what was that? Was question 4, yes. So that wasn't too bad because they gave us that formula and then we can solve that formula for X. So that's what we had to do, find the X value. Now, number 6 is more like the one that we did in the PowerPoint, except it's a circle. And they have it all nice and pretty here. The circle is at the origin. The center of the circle is at the origin. So that is really nice. So we want to at least write down our formula once again. Density times the height. And then the cross section, the X values. What do we say? LY. And we're taking the derivative with respect to Y. Here, the depth. Well, let's see. The cylinder of gasoline is placed so that the X-axis in the cylinder is horizontal. Find the fluid force of a circular end of the tank when the tank is half full. So that's really good. I hate that they put this ring up at the top, but it's half full. The bottom half is full, not the top. So that's right on the X-axis or Y0. So our height of the fluid is going to be below this. So we're going to have minus Y. So there's no fluid in the top.
So if the tank was full, would we then need to
I
push the
would-
entire circle below?
That's what I would do. Yes.
Okay.
Yes. That's exactly what I would do. Okay, so it's half full. And now we want the formula for this circle. We need another formula there. We found the formula for that line for the trapezoid. But here, let's try to get the formula for the circle. And circle formulas are x squared plus y squared equals r squared. And if you look, did they tell us it's where the diameter, if the diameter is 3, so that's 1.5. It says up here, the diameter of the circle is 3, so that's 1.5. So R equals 1.5 squared. That's the radius. This radius right here is 1.5. And we want to solve this for X. So that's what we're going to do. I think it's easier if we do this, if we put 1.5 is 3 over 2 and then square it, because then we get 9 over 4 x squared plus y squared. Take the y to the other side. X squared equals 9 over 4 minus y squared. Square root both sides. Square root square. X equals. Now watch what I do here, because I see the bottom has a 4. So I'm going to do 9 minus 4y squared. What I'm going to do is I'm multiplying. I'm not changing it. I'm just making it look different. I'm putting 4 over 4. I'm just multiplying it by 1. So they have a common denominator. So this whole thing is over 4. Everybody okay with that? And then
I'm glad you showed us, because I would not have known what they did if I just looked at the stuff.
Oh,
on the
yeah,
left.
yeah. You know, you can. If they don't show you the algebra, they assume you know how to do algebra in all these solutions. And if you remember your rules on square roots, you can break this square root into 2 parts. And the square root of 4 is 2. So this is 9 minus 4y squared over 2. So I mean that, and if you look, okay, so this is our ly. And what they did was they took, if you look the ly, they took the 2, this 1/2 out of there. Do you see? There's the 1/2. There's the over 2. And don't forget, we have to multiply the x by 2, and there's where they multiplied the x by 2. The 1/2 comes out, and we had to multiply it by 2. So these 2 will cancel when you put it into the ly, and so there is the whole ly after we canceled this stuff up here. Okay, so I just wanted to make sure everybody understood that we had to take that x times 2, because all we did was find this x value, but we had to find the distance. That ly is the distance all the way across, the horizontal distance across at any given point. All right, so now that we have this, I'm going to erase all of this. And we have this part. Oh, well, we don't have that part yet, but equals, can somebody tell me where they got 42?
Density gasoline weighs 42.
Yeah, this is the density of gasoline. So they gave that to us. So 40, so that's, the formula is W, and we're integrating right here, down here is -3/2, but we're integrating from -3/2 to 0 because it's only half full, from -3/2 to y0. And then we had -y below there, and we had the 9 minus 4y squared. Okay, so then we go to the same process as last time. It just becomes a big mess. Let's see how they did this. Oh, I see how they did this now. Okay. We have to integrate this. To our shock, we have a real integration problem. Over on the side, so here we actually have a integration we need to remember. U equals 9 minus 4y squared. The derivative of u ends up being -8y. So if this is u, this is du. If I put an 8 right here, if I put an 8 right there, I have to put a 1/8 here. Okay, so now in reality, we're integrating the square root of u du. Or we're integrating u to the 1/2 du. So when you integrate u to the 1/2, you add 1. And you get u to the 3/2. Then you got 3/2. So there's the integration. We're done with the integration. We're integrating it from -3/2 to 0. We still have the 1/8 times the density in front of it. 1/8, and the density was 42 for gasoline. And then the last step is putting the u back into here. And that's what they did. If you look at this last step, they put the u back in there. This is 42. I'm missing something. The 3 is right here, the 2/3. This 2/3, if you're trying to match it up with over here, you can put this 2/3 here. Let me erase that 2/3 so it matches what they have. Yeah, 21/4, these reduced by 2. So now we have the 21/4, we have the 2/3, we have the 9 minus 4y squared to the 3/2. And then we integrate it here. They do, I'm not going to put the numbers in there, but you put the 0 in there, and then you subtract and put -3/2 in there, and you should get something like this. So, I mean, I think the hardest part about this is how do you integrate this at the end? And you had to remember, oh, this is just u du. And you had to put the 8 there and the 1/8 there. So they didn't really, they don't tell you all that in the solutions manual. That's why it's always good to go through this. I think the key for all of this is, getting that ly. Is being able to get ly correctly, and that's using if you have that trapezoid. So now that you just find the equation for a line. A circle, you're going to use the equation for a circle: x squared plus y squared equals r squared, and then use that and then solve for x for both of those that you have to do. All right, I think that's all I had for the day. Let me hit stop recording, and then you can ask any questions you want if you have any.